Because what you are doing, if you want this one, the x to be just is 1. The y is what? It's going to be 1.
Yeah.
It will be just a 1 space. 3 rows. 2 is the 2 by 1, right?
Yeah.
It's going to be a 2 by 1. But this one was a 2 square one, which is a 2 by 2. You know that this was a 2 by what? 2. Hey. But now there is that when you take a 2 by 2, multiply it by this one is a what?
2 by 1.
A 2 by 1. You should multiply by 2 by 1. Right? Then that you are getting there is again is a 2 by what? 2 by 1. Now what we are saying is this. When you take this matrix, when this one is the x, y is 0, x, y is 1. And then you are corresponding with, you are multiplying it by x and y. In other words, that the elements in what you are saying when you multiply by x and y, the answer you are going to get, your x is going to be a, your y is going to be b. In other words, x is going to be a. Y is going to be what? B. What's the word? Your x is B is equal to A, and your y will be B. Let me just do what? Because the issue is corresponding. Assuming this one. 1, 0, 0, 0, 1, 0, what is 0, 0, 1. It's an identity, right? It's an identity. I is an identity matrix. I is an identity matrix, right? Assuming that this is an identity matrix. And then, if you put this one, it is corresponding to what? This is when you are multiplying by, when you talk about this one, it's the same as x, y, what? Z. So, this it will be corresponding. Whatever element from A is corresponding to, this is A, this one B, this one is what? C. What does that mean? It means it's most bakare A, bakare B, bakare C. Bakare is my number. If you put my number as B, the number will be A. This is your A. Assuming that this is your A. Assuming that this is your B, this is your C. It appears to be the same. That's why when you multiply this to that, you're going to come up with this matrix, which is it's going to be where x is equal to what? A, y is equal to what? B, and z is equal to what? Is equal to C. Right, let's go for examples. I think maybe the example. Let's go for the example. I think the example. So the article corresponds to x is equal to A, y is equal to B, C is equal to. When we multiply the matrix by one of these matrices, the original matrix is unchangeable. The fact is very simple in solving matrix equation. Right, let's look at the definition. Identity matrix. And n by n is like 2 by 2, right? Is that a square matrix, right?
Yes.
N by n. Right? It's an identity matrix.
Yes.
Right. And n by n identity matrix is denoted by n. I. No. Right. Can you read that? I think you are tired. Can you read that for you?
The n by n identity matrix is denoted by I denominator n. Just I when there is no possibility of confusion. Is the n by n matrix consisting of ones on the main diagonal and zeros everywhere else?
It is not about the diagonal when you put line like this, right?
Yeah.
But you have something like this. In other words, it goes like this, right? One is here, one is there, one is there, right? But we use have 0, 0, right? After 0, 0, 0, right? 0, 0, 1 like that, right? That's what they're talking about, eh?
The main diagonal consists of those entries in the first row, first column, the second row, second column, and so on down to the end row, end column.
What does that mean? You identity matrix. I think the identity matrix which is IA. It can have, so it's not only this one. It can take the whole board, the whole whiteboard in, right? One up to the last one. Then, you can provide it, you have to place the zeros and one stuff, right? As we are saying in the binary, zeros and ones. Because what you are adding there is anything to do with the zeros and ones, that is what is called identity. Right? Which is denoted by I.
Every identity matrix has the form, this one. If the matrix A and B have appropriate order, so that the matrix products are defined, then AI is equal to A and IB is equal to B. Thus, the identity matrix serves as the multiplicative identity on the set of appropriately sized matrices. In this sense, I serves the same purpose. In this sense, I serves the same purpose as the number 1 in the set of real numbers. We know that the linear system of n equations.
In other words, what they are saying that when you take a matrix A, you multiply by the identity. The answer you are getting there is what? When you take a matrix A, you multiply by identity. The answer you are going to get is that matrix A.
Oh, the
colors are included here. If you take, for example, you are taking a yard 0 by 1. If you take an identity matrix I, if you take a matrix A, assume the matrix A, you are multiplying by an identity. The answer you are getting is A. If you take a matrix B, and that matrix you are multiplying by identity.
What's the identity?
0, 1, 1, 0. You are multiplying by identity. What you are getting is a B. You are not getting an identity. For example, let's look at this one. 3, 1. Let's look at the matrix. 3, 1, and what? 2, 0. Yes? You want to take this one, multiply by 0, 1 is 0. When you multiply by this, the answer you are getting is this one. Have you tried?
Yeah.
Try.
You multiply by that?
Yeah. It's the answer. Yeah, if you are multiplying this is your A, multiply by this is an identity I. Find out what's the solution. You are not going to answer, right?
No, it's small.
Bang, that's like